I am about to explain you the core of the special theory of relativity in a way that even a 10-year-old kid could understand. This is how it works. We need a pair of Cartesian axes, x and y. They are depicted in the figure in blue. Now we'll define two new axes that result from rotating the old ones by 45 degrees. We'll call them r and L. We need now a straight line, starting at the origin of coordinates and sitting on the first quadrant of our new red axis. Here you have an example with a slope or gradient in those axes equal to 1/4. The square root of the slope of this line will be what we will call our contraction factor. It will be 1/2 for that line, since 1/2 times 1/2 is 1/4. There are more options, of course. Here you can see another one, for which the slope would be larger, and another one for which the slope would be even bigger than 1. We now choose some points in the plane. Our goal is moving them to a different location. I will start with 4 points sitting on the r and the L axis, since the way they will move is very simple. Here you have them. The one on the top right has coordinates x equal to 4 and y equal to 4. The way we move points is as follows. We use our contraction factor to reduce the distance of all points to the L axis. Let's do it. We see that the 2 points on R move towards L, reducing their distance to it by half. The new coordinates of the point we mentioned before will then be x equal to 2 and y equal to 2, for example. The 2 points on the L axis did not move, since their distance to L is 0. We now perform the second part of the transformation. We increase the distance of all points to the R axis by the inverse factor, that is 2. Let's do it. Note that the points in R did not move this time, since they are at no distance from R. Now we'll take a look at a point which does not sit on the red lines. Here it is. We take it to be a point on our yellow line, but it could be anywhere else really. The coordinates of this point are x equal to 1.5 and y equal to 2.5. Let's see how it moves. First, we contract along the r direction by a factor of 1/2. Here it is. Now we expand along the L direction by a factor of 2. Here it is. The point ends up on the y-axis, where x is equal to 0 and y ends up being 2. Now you should play this game with other points. Be sure you understand how it works. You can also choose yellow lines with different slopes and the corresponding contraction factors. That's it. That's the special theory of relativity. All you have to do now is thinking of the y-coordinate as the time of an event in seconds, and the x-coordinate as the position where the event happens, measured in light seconds. That is the distance that light travels in just 1 second. The yellow line will represent a different observer moving at constant velocity. Think about a moving train, for example. The new time and position coordinates resulting from our transformation will be the time and position coordinates of the same event according to the person in the train.